equals 3x squared plus 2y squared.
Okay, that's it?
Yeah.
Okay, perfect. So we differentiate both sides. This is the product rule. When I differentiate this function that I don't have, I have to write dy over dx times this function plus the first function times this function prime. So far so good?
Yeah.
The right hand side is 6x. I don't have the function, it's just a variable, the independent variable, plus bring down 2, subtract 1 from the power, and now I have to differentiate the inner function prime. Is this okay? So far so good?
Yeah.
Okay, so now this is the variable. We have to have it all terms with the variable on one side and the term without the variable to the other. And when I move this here, this term becomes negative. So I have cosine x minus 4y times dy over dx. I factored out already, equals 6x plus y sine x. This term is negative y sine x, and I move it to the other side, it becomes negative. And now at this point I divide, so I have dy over dx equals 6x plus y sine x over this, cosine x minus 4y. Is that okay?
Yeah.
Thank you.
Can we do number 14 from the old test?
Yes. Let's look and see what it is. You said number 14. Old test. Old final. Okay. Number 14. Three, 5, 6, 8, 12, 14. So what, yes, of course we'll do it, but what is the problem with this? What do you think I should have explained more, or?
I just want to go over, for me, I want to see you, like, go over each one. Like,
Okay.
In the old exam.
Okay. So the integral from 0 to 16, from x plus 1 to the third, tangent the square root of x plus 3 dx. And the interval is given to us, and we are asked to use 4 subintervals. So for the interval, to divide it in 4, so we have delta x 16 minus 0 over 4, which is 4. So this starts at 0 and plus 4 and plus 4 and plus 4 and plus 4. The midpoint here will be 2, the midpoint here will be 6, the midpoint here will be 10, the midpoint here will be 14. So then this will approximately equal delta x, which is 4, times f of 2 plus f of 6 plus f of 10 plus f of 14. F of 2 plus f of 6 plus f of 10 plus f of 14. So in this function, I have to plug in 2, 6, 10, and 14. So I will plug in the function in the graphing calculator. I will share my screen. So where is my, here it is. So what I would have done with this function, I would have gone to list, edit, clear my lists, In list L1, I will enter 2, 6, 10, and 14. 2, 6, 10, and 14. And in list L2, I will highlight list L2. I will write 4 in parentheses. List L1 plus 1 to the third power. And then tangent of list L1, square root first, of list L1 plus 3, and then close the parenthesis. I'm checking my calculation, so this list L1, yes, 4 comes from the delta x times f of 2, this will be f of 2, and then f of 6, and then f of 10, and then 14, and I have x plus 1 to the third. I do tangent the square root, yes, list L1 plus 3. And when I press enter, sorry guys, where is my enter? Oh, I was looking to the right. Okay, here's my enter. I get all these numbers, and then I will have to add them up. How do I do that? I go to stats, one variable stats for list L2, and calculate, and it will add up perfectly exactly what I want. 22524.75891. Of course, this is not the only way. You can just do it one by one and add them up. It's up to you how you perform the calculations. Any questions? Yes.
Question on that one?
Yes.
What number did you get on 14 on the final solutions for the one you gave us? Because that's not the same answer we got.
So I was just looking at that. So f of 2, f of 6, 10. So let me see what I did. Thank you. I was going to look at that. So let's see what I did. I'm sharing my screen. Where is my calculator? Let me look at the stats list. So I did have 2, 6, 10, and 14. And list L2, I'm going to do it again. So it was 4, because it's delta x. And then the function, one more time. The function was list L1 plus 1 plus 1, and close and power 3. Okay, tangent. Okay, I'm going to put the square root, and I'm going to put parentheses in the square root. So this is list L1, and then plus 3. Close the parenthesis, and go outside, close again. Okay, let me do it again in a different way then, because I get the same thing. So maybe I have an error on in the solutions. So 4 times in parentheses. So we have 2. 2 plus 1 is 3. 3. No, I'm going to put parentheses. 3 to power 3. And then tangent. Oh, okay. So 2 plus 1, 3 cubed. Yes, tangent of 2 plus 3. So it's the square root of 5. Okay, plus. Now we plug in 6. 6 plus 1 is 7. 7 to the third. And then tangent again. And in parentheses, the square root. What we have in the square root, 6 plus 3 is 9. The square root of 9 is 3. But I'm going to write it because I have the square root already in there. It doesn't matter. Plus. Now we plug in 10. 10 plus 1, 11. Oh. Plus 11 to the third power. And then tangent again. And this is 10 plus 3, the square root of 13. And close. And the last one, plus 14 plus 1 is 15. 15 to the third power. And then tangent again, and the square root. And again, we're plugging 14 plus 3, so that's 17. Go outside, close the parenthesis, and close the other parenthesis for the 4 in front. So I didn't copy the correct answer. So on the paper, that's my mistake. So it's 22524.75891. So I'm wondering if I forgot to multiply, where was it? Oh, I didn't mean to stop sharing. So I was wondering if I forgot to multiply by 4. No, that's not it. No, because 10,000 times 4, it was not going to be that. It was 2, 4, 6, 2, 6, 10, and 14. Not sure. But thank you for pointing that out. So it was 2, 6, 10, and 14. So this is the correct answer. Okay, so one variable stats will always give us, oops, just that, the sum of the list L2. So this is the sum. This is the average. So this is what we need. So we got the same thing twice in 2 different ways. I must have copied something wrong on the paper. The final answer is wrong. All the rest is correct. My apologies. Good. So we checked in 2 different ways. It must be correct. Very good. Next question. Thank you. Anything else?